Hey, hi, good morning, everyone.
Morning.
Good morning.
Good morning.
Good morning.
Good morning.
Morning.
Good morning.
Okay, let's start. So yesterday, before we concluded the class, yeah, we were discussing this, right? The different kind of variables that we have. We have categorical variables, that is the qualitative variables, right? And then we have continuous variable, that is the quantitative variables, right? Categorical variables are also called qualitative variables because it tells us the quality of something. And continuous variables are also called quantitative variables because it tells us the quantity of something, like how much is something. Now, in categorical variables, we have mainly two types, nominal and ordinal. Nominal means no order. Okay. Similarly, ordinal means that there is an order in the the variable. So, for example, gender, name, colors, they don't have any order in themselves. On the other hand, your rank in a military, or let's say ranking in a race, uh, do have an order in it. Similarly, income category like high, medium, low, uh, this also has an order in it. But we cannot do any mathematical operations on this. So, for example, we cannot say that in a race, rank 1 plus rank 2 is going to be equal to rank 3, right? I cannot do addition, subtraction, multiplication, division on these variables. Now, that's one thing. Then we have right. So we have then continuous variable. The continuous variables are of two types: interval variable and the ratio variable. Interval variables are the one where the true zero is not defined. Right. So, for example, temperature is an example of interval variable. Here, the difference makes sense, right? But the multiplication will not make sense. So, for example, 0 degrees Celsius, this 0 degrees Celsius is not the absence of heat. 0 degrees Celsius is your freezing point of water that we have taken as a reference. Okay. If we want to truly measure heat, then it should be measured in Kelvin. Okay. So 0 Kelvin, for example, means absence of heat, and that means that once things reach to 0 Kelvin, we cannot make it any cooler. Why we cannot make it any cooler? Because to make anything cooler, you need to remove heat out of it, and at 0 Kelvin, we assume that there is no heat left in the system now. Okay, so now another example of your interval variable will be time, right? For example, we are in 2025 as of today. Okay. When we will reach to, let's say 4050, right? Let me write it down. Let's say when we will reach, currently we are in 2025. When we will reach in 4050, right? Will we say that now that twice the amount of time has passed as compared to what passed between 0 2025? Answer is no. The reason being is that the true zero for time is not defined. Okay. Do you know what is considered as zero year?
Century?
No, Jesus Christ, like the born of Jesus Christ or something. AD.
Right. So there is the concept of AD and BC, right? Before the birth of Christ and after the death of Christ, right?
Yes.
What does that mean?
Like before the birth of Jesus Christ, it is
Hmm.
BC, before Christ, known as,
Hmm.
and after the time period after his birth is known as, like,
Right. Exactly. So, but this zero is when we say zero calendar year, does that mean that there was no time before the zero calendar year? If calendar is the measurement of time, if the dates are measurement of time, right? Does zero calendar year means that there was no time before it?
no.
No, right? And yeah, as correctly pointed out, it is a reference point. Zero calendar year is a reference point. Okay. Uh, it means that it is defined by us. It is not something which naturally exists. For example, zero height is not something that we have defined. We know that zero height means that that thing doesn't exist. Zero mass means that that thing doesn't exist. It's not like that the people came together and they decided that, okay, this point looks like the point that we can call, we can start calling it as zero. Okay, no. So similarly, time, because the zero is defined by us, it is the reference point, right? It is an example of interval variable. So we can say that between the time which has passed from 0 to 2025 and between 2025 to 4050, that interval is defined between 0 to 2025 also there will be 2025 years. Before between 20 to 25 to 40 50 there will be again 2025 years. So the interval is defined. For example, again between 0 degrees Celsius to 25 degrees Celsius there is a change of 25 Kelvin. Okay. Similarly, from 25 degrees Celsius to 50 degrees Celsius, there is again a change of 25 Kelvin. So subtraction and addition is allowed, but multiplication is not allowed. Okay. As I was telling you, when you are moving from 0 to 20 degrees Celsius, right? And versus when you move from 20 degrees Celsius to 40 degrees Celsius. Okay, you cannot say that a thing which is at 40 degrees Celsius is twice as hot as the thing which is at 20 degrees Celsius. Okay, we cannot say that the thing which is at 40 degrees Celsius is twice as hot as a thing is 20 degrees Celsius. Okay, because what is 20 degrees Celsius? 20 degrees Celsius is 293 Kelvin. Okay. Similarly, what is 40 degrees Celsius? 40 degrees Celsius is 413 Kelvin. Okay. So what is the percentage change that we have over here? It is just 413 minus 293 divided by 293. This is how much time hotter 40 degrees Celsius is from 20 degrees Celsius. Okay, not twice as much. So the differences are allowed, but multiplication and division is not allowed in for interval variables. All the other variables that you can think of, right, will always go into ratio variable. For example, mass, height, uh, age, right? Zero age is not something which is a reference point. Zero age is something which exists. Okay. Can you give me any other example of ratio variable? Can you give me any
So,
other?
like interval variable, zero is not defined. So,
Right.
in to understand what the value of zero, we need a context. Is it right? We
Right.
need like something to relate it with to understand what zero here is. Like it can be anything, internal variable apart from temperature and like it can be
Hmm.
anything. But
Hmm.
internal variable to understand it, we need context. Is it like I'm understanding it correct?
No, that's correct. That's correct, actually. Yes.
Okay, okay.
Hey, sorry for that. right? So yes, for interval variables, there is no zero defined. It is a reference point. On the other hand, for ratio variable, the true zero is defined. Example of ratio variable, what it will be? Ratio variable, the example will be
Height, it can
uh,
be height, weight,
Age, height, weight, income.
weight,
right height. Like very nice, right?
marks, or score.
Income will also be an example of it, right? Although income category is a categorical variable, right? But income in absolute term, it is a continuous variable. Similarly, if I will have age, groups like that, let's say 0 to 10, 10 to 20, 20 to 30, what kind of variable that will be? Let's say sorry,
Continuous.
We are
no,
categorizing it. I mean,
right. If it is
No,
between 0 to 10, 20 to let's say 30,
it's interval variable, right?
no,
They're defining zero.
no, nothing like that. See, it's not like whether you're defining zero or not. Don't think from that perspective. Let's say we call income category as a ordinal variable. Why?
Because like income category can be seem to be a they can it can seem they have no order, but they still have order like some kind of I don't know.
Right, exactly.
Yeah.
Because let's say when it comes to let's say low income, when it comes to low income, high income, right? Let's say low income, medium income, high income, right? There is an order in it, right? We know that like it will be low, then it will be medium, and then it will be high. Okay. But whether it is a categorical variable or a continuous variable, to decide that, you need to first know whether you can do any mathematical operation on this or not, right? Can I do this kind of operation, like this statement in itself, like medium minus low, right? Does it make any sense,
No,
right? Or high minus medium or low plus low, will it become medium? No, right? I
no,
cannot do any mathematical operation on this, right? But let's say, if I have age 0 to 10, yeah, 10 to 20, 20 to 30, and 30 plus, right? Even here, you cannot do any mathematical operation, right? Can I say that 0 to 10 plus 0 to 10 is equal to 10 to 20? Is it true?
no.
Right? So
Because
because as
they are age, that's why we can't do like this kind of operation yet. Because it doesn't make sense to add
right,
up ages.
right, exactly, right? So because we cannot do any mathematical operation on this variable, okay, it is a categorical variable. But is there any order in it? Can I say that this comes first, then this comes, then this comes, and so there is an inherent order
Yes,
in it, right? So
yes.
because it has an inherent order, it will be an example of ordinal variable, right? So it is a categorical variable because we cannot do any mathematical operation on it, but it is an ordinal variable because it has an order in it. Okay. Similarly, let's say let's talk about satisfaction survey, right? Like sometimes the company roll out satisfaction surveys to the employees, or let's take an example of rating of restaurant. A restaurant ask you to rate between 1 star, right? 2 star, similarly till 5 star. Is it an example of categorical variable or continuous variable?
Categorical.
Continue.
Categorical variable. And in categorical variable, what?
Ordinal.
Ordinal variable.
ordinal.
Or
Ordinal
ordinal
variable.
variable, right? Because there is an order in it. But similarly, I cannot say that one-star rating. If someone is giving me a 1-star rating, plus if I will take a 4-star rating, that will become a 5-star rating. I cannot do that. Right? Similarly, satisfaction surveys, right? Your how much satisfied you are with our services, and they will ask you to rate them between 1 to 10. Okay, this satisfaction survey is a type of categorical variable, and it is ordinal in nature. Okay, so although you will be seeing numeric values like 1, 2, 3, 5, 7, 8, like these kind of numeric values you will be seeing, but it is an example of categorical variable. So it's not like that whenever you will see number, it is going to be continuous variable, and whenever you will see the string or a English, you will think that it is a categorical variable. That is not correct. Okay, what kind of variable phone number is?
Categorical variable.
Should be
Categorical?
nominal.
Nominal
In
and
categorical, yeah, nominal variable.
nominal.
Exactly, right? So it is a nominal and like categorical variable, right? Because it doesn't have any inherent order in it. You cannot say, you cannot subtract to, first of all, it is a categorical variable because you cannot subtract two phone numbers. You cannot add them, you cannot multiply them. So we cannot do any mathematical operation on a phone number. Same goes for bank account number as well. Bank account number is also an example of categorical variable, and they all are nominal variables because there is no inherent order in it. So if my bank account number is bigger than your bank account number, that means nothing. Okay, because it is just a randomly generated number. Okay. Any question on this? Okay, if there is no question, let's move to the next one. Okay. The next part is where to use which kind of charts. Why we are discussing that? Because data presentation is also very important part of statistic. You know the numbers, but how you want to portray it, right? That is also very important. Like, and there's fixed defined rules about where to create which kind of chart. Okay, so a few of you might already be aware of it. So I will just give you a very high level overview of it.
Actually, wait, I have a like question in interval variable. Like apart from temperature, like uh, what we can like assume that is a internal variable apart from temperature. Can like score
Uh,
like mass score like mm, exam score also can be a interval variable, right? Like if a person get like zero in it, it doesn't mean like it have a like total absence of knowledge, right?
no, but let's say, for example, if you will get zero in your mathematics exam, right?
Mm.
In mathematics exam, it is an example of a ratio variable. Okay, but
Okay.
your IQ level is something which is an example of interval variable. Okay, zero IQ is something which is defined by human beings. Zero IQ doesn't mean absence of intelligence.
Hmm.
Okay,
Okay.
so yes, IQ score will be an example of interval variable, but your marks scored in mathematics will be an example of ratio variable. Because there 20 is defined. Like if you got, let's say, 10 marks versus 20 marks, can I say that you got twice as marks as before? Yes, that is correct. Right? But let's say if someone is having a IQ score of hypothetically 200 and other person has an IQ of 100 score of 100, can I say that the other person is twice as smart? No.
Okay.
Uh, and yeah, I think that's it. Okay. So no, Charan actually, so Charan's question is that if there are any variable where the variable value is string, but it is defined as a continuous variable, no, that is not possible, Charan. Right? Other way around is possible, that the value is numeric, but the variable is defined as categorical variable. But it is not possible that the value is a string, but it is a continuous variable. So other way around is not possible. Okay. Now, because we know what is continuous variable, what is categorical variable, um, let's quickly try to understand what are the different type of charts that we have and where to create what kind of a chart. There are fixed defined rules for it, right? And we should follow them. Like it's not like it is a recommendation. It is a rule. Okay. Now, whenever we have one variable as a categorical variable and another variable as continuous. Okay, one variable as categorical variable, another variable as a continuous variable. What kind of chart we should create? Right? Let's say I have,
We can use bar
uh,
chart here.
Pie chart, histogram.
Bar chart can be
Bar
useful
chart.
here.
right. We should create bar chart here. Let's say on the x-axis, if I have state, what kind of variable state is? Like Punjab, Haryana,
Categorical.
categorical variable, right? And let's say on the y-axis, I have number of people, that is the population.
Hmm.
What kind of variable population is?
Continuous.
Continuous
Categorical
variable, right? So population is continuous variable. The state names are categorical variable. If I want to create a chart between a categorical variable and a continuous variable, it will always be a bar chart. Always be a bar chart. Right? And I will discuss where we will be using pie chart and all. But this will always be a bar chart.
Why population is continuous?
So first of all, can we do any mathematical operation? Yes, let's say hypothetically again, if India's population is 100, Pakistan population is, let's say, 20. If tomorrow we merge India and Pakistan both, can I say that the country's population will be 120? The answer is yes.
Okay.
Right? So I can add populations and I can subtract population as well. So for example, when the division happened, right? If India's population was 100 and we divided it into two parts, India and Pakistan, and let's say India got 70, Pakistan got 30. So yes, it can be subtracted. The Pakistan got subtracted from India, from the population perspective, right? Can we multiply it? Yes. If at one point of time India's population was 100 and now if it is 200, can I say that now we have twice as many people as before? The answer is yes, right? So it is actually a ratio variable because even the subtraction and addition makes sense. Apart from that, your multiplication and division will also make sense. Okay, and true zero is defined. There can be an island. If there is no one there, we can say that it has a population of 0 people. And this is not something which is a reference point, right? 0 people means actually 0 people. There is no one there,
Okay.
right?
Thank you.
So population is a continuous variable.
So wherever there are numbers and that can be, summed up and subtracted, those are continuous variables.
Right, right. Yes, exactly.
No.
Okay, so I have categorical variable and a continuous variable. It will always be a bar chart, right? Without any exception. Okay, now when we have on one axis, if I have time, anything in time, like it can be years, it can be days, it can be minutes, it can be second, anything if you have it in time, and the other variable is the continuous variable. Okay, it is always going to be a line chart. What can be the example? Let's say,
Analysis, like stock analysis,
very
like
nice.
period of time. In this period of time, the stock like changed how much,
Very nice. What else?
high and low. What else? Population we can also,
Right, exactly. Very nice. Population we can also plot. What else?
anything like relating to time,
Mhm.
we can use it like
Year
Number
by
of number of
progression.
products sold
Number of
over
products
time.
sold. Right, very nice.
Year by company progression.
Right, let's say I'm assuming the progression you mean revenue or sales, right?
Yes.
Right, then yes, we can put sales here. Right? Because sales is a continuous variable, or number of orders, or revenue, right? Or expenditure, or let's say the stock price, anything which is continuous, right? Property rates, right? So we can put, if we are plotting it with time only, then it should be a line variable. Oh, sorry, line chart. Okay, whenever there is a time, never make a bar chart. Like it will look wrong. Similarly, whenever there is a categorical variable, never make a line chart. Okay, with categorical and continuous, it will always be a chart, bar chart. With time and continuous variable, it will always be a line chart. Okay, now the other type can be continuous versus continuous. One variable is a continuous variable. Another variable is also continuous. Okay. So in this case, what kind of chart we will be creating? Let's say if I have height and weight, if these are the two I have, what kind of chart we will create?
Scatter plot.
Scatter plot, right? If I have one variable as height, other variable as weight, okay, it is going to be scatter plot. Here, what does each point means?
That person
What is
can wait.
right? That person's height and weight. So each point is an individual on this chart. Okay, so this will be an example of scatter plot. Now, I have continuous versus continuous. The other example of, other type will be categorical versus continuous again. Categorical versus continuous again. But this time we are looking at the proportions. Okay, if we are looking at proportions, right? For example, if I created a circle, Now, right? Let's say, for example, contribution of different sectors in the India's GDP. The sectors are nothing but your categorical variable. Let's say, for example, manufacturing, your manufacturing is there, IT is there, your services, farming, right? All of these are different sectors which contributes to GDP, right? And if I want to see that, how much each sector is contributing to our GDP, then what we can do is maybe we can create a, maybe we can create a pie chart, because that will show me the proportions, right? It will add up to 100%. So I will get to know that, okay, how much IT is contributing. I will know that, okay, how much is your manufacturing is contributing, how much is farming is contributing. Okay, so this is GDP by different sectors. Okay, so I can say that maybe this is, let's say, 20% is contributed by IT, right? Let's say 40% is contributed by manufacturing, right? Similarly, I can say that 30% is contributed by farming. So it should add up to 100%, right? So let's say 40, this is 60, 70, 80, 90, and this maybe 10% is others. Okay, so when you are trying to show the proportions, then we can use a pie chart. Okay, there is one thing that we should remember about the pie charts, that use pie charts, first of all, only when we are showing proportion. That is one thing. Second thing is when the number of categories are less than equal to 5. When the number of categories are less than equal to 5. If the number of categories are more than 5, try to avoid pie chart. The reason being is then it becomes a little cluttered and it's too difficult to understand. Okay, so if possible, create pie chart only when they are less than equal to 5 categories. If they are more than that, more than 5 categories, then we should use some other chart. Most of the time, actually, bar chart, because there are only two options. Either there can be a pie chart or there can be a bar chart if I have categorical and continuous variable both. So only two options are there, bar chart and pie chart. If I'm showing proportion, use pie chart. But even if I'm showing proportion and the number of categories are more than 5, then use bar chart. Okay. The point being is, it should be easy to read. Even if there are 6 categories, 7 categories, does not matter, right? But it should be easy to read. What my experience says is when it is more than 5 categories, it becomes a little difficult to read. Okay.
Can you please give the example for line chart also? If it is categories are more than 5.
Okay. Now the last kind of chart is Anisha. In that case, we will use bar chart. Okay, and the last kind of chart is box plot. We use box plot when there is only one variable, and that variable is continuous. If there is one continuous variable, then we use box plot. How the box plot look like? It looks something like this. Okay. If anyone follows stock market, you might have seen these kind of candles also, right? Although it is not an example of box plot, but yeah, it is similar to that. Okay. Now, how to create box plot and how to read it is something that we will try to understand now. Okay. I have not discussed a lot on bar chart, line chart, right? Scatter plot, because I feel that those are comparatively something that you are using already for some time, right? So you will know that what a bar chart is, what a line chart is, what a scatter plot or pie chart is. Okay, but we will spend some time on the bar chart. Okay, because I feel that if you are not working in stats, sometimes you don't have exposure to the bar. Sorry, not bar chart, box plot. You don't have exposure to the box plot. At least I have never used it. In my college or in my school. So this is something that I believe that we use it when we are working as a data analyst, data scientist, right? If you want to see the distribution of a variable, but not something that it is being extensively used outside. So we will cover this one. Okay, how to create box plot first of all, and how to read it. Okay, a box plot will look something like this. There will be a rectangle box, and then there will be lines extending from that blue rectangle box. These things, these lines that you see, okay, these lines are called whiskers. These lines are called whiskers. Okay, and there will be one line in between as well, like somewhere here. Okay, and now how to read a box plot? In a box plot, there will always be 5 points. Let's call it, this is 1 point, which is important. This is the second point, which is important. This is the third point, which is important. Fourth point. And this is the fifth point. Okay, now what each of these points are? The first point that we see over here is the minimum value. The minimum value of a variable, of that variable. What is this middle value? This is the median value. This is the median value. Okay. What is this last thing? This is the maximum value. Right? I believe out of at least these 5 points, you already know 3 points: minimum, maximum, and the median. Okay. What are these 2 points? These 2 points are nothing but 25th percentile and 75th percentile. Okay. This point is nothing but 25th percentile. What is the meaning of 25th percentile? It means that 25% of the data points are less than this value. Less than this value. That's what 25th percentile means. let's say, these days, because this IIT mains results are coming, right? They give you a percentile score, right? That you have 75th percentile or 80th percentile. What is the meaning of that? It means that you are ahead of those many people. If you've got 75th percentile, it means that if 100 people have given, if 100 people have given the exam, right? You are at 25th position, right? Because there are you are ahead of 75 people. You are ahead of 75 people. So 25%, 25th percentile means that you are ahead of 25 people. Okay. Similarly, the fourth point that you see over here, this point that we see over here, that is a 75th percentile. Okay. It means that you are ahead of 3/4 of the population. Okay. So these 5 points divide the population. My kid is a little cranky today. So these 5 points that you see over here divides the population into 4 equal parts, right? If you look at this, here we have 4 equal parts. We have 5 points, but we have 4 equal parts here. Equal part in terms of percentage population, not in terms of width. This width that we have over here, this one, this is one part. This is second part. This is third part. This is fourth part. Right? So in each part, right, the width is different. From here to here, this width is definitely smaller as compared to this width. Right? So when we say 4 equal parts, I'm not talking about the width. I'm talking about the percentage people in each range. So from here to here, right, from this value to this value, there is a 25% people are there. Similarly, between this point and this point, 25% people are there. This point to this point, there are 25% people which are there. Similarly, from this point to this point, again, 25% people are there. So these 5 points divide the population into 4 equal parts in terms of percentage population. Okay, median, anyway we know, right, is the middle value, right? It means that there is 50% of the population which is less than this value. There is 50% of the population which is greater than this value. Okay, that is the median value. Okay, so this is how we should read a box plot. Right now, the thing is how we are going to create a box plot. To create a box plot, all you need is 5 points that I have mentioned over here. 1, 2, 3, 4, 5. One is the minimum value, one is the maximum value, one is the median value, and one is the 25th and 75th percentage.
So what are these whiskers? So, is there any meaning for whiskers?
No, actually, there is no meaning of it as such. Like, these are called whiskers because it looks like whiskers, right? Like a cat has a whisker or a dog has a whisker, right? Those small hairs that they have around their no, like that, those whiskers, because it looks like whisker, they're calling it whisker. Otherwise, no meaning to that.
And percentile is similar to the percentage, you mean to say, right? Percentile
Right,
is
right. It is similar to percentage. It's just that it's mainly used in terms of what percentage of population is below or above this thing.
okay. Yeah. Thank you.
Okay, to create a box plot, we will be needing 5-point summary, right? What is the 5-point summary that we have? It means that you should know the minimum value, you should know the maximum value, you should know the median value, and you should know the 25th percentile and the 75th percentile. Okay, always imagine box plot like this. So we need to create this. So I always imagine box plot like this, that we have 4 equal quarters. In each quarter, there is a 25% population which is sitting. Okay, to create a box plot, we will be needing the 5-point summary. Okay, let's try to understand it with an example. We have different values, like we have maybe 35, 35, 25, 28, 29, 30, 38, 34, 37. Okay. Now the first step is, let's say when you will get this kind of a data, right? The first step is always to create to sort this data. So I will sort it. Start with the smallest value is 25. Then I believe we have 28 and 29. Right? Then I have 30. Then I have 34. Then I have 35, 35. Then I have 37 and 38. Okay. The first part is always sorting the data, right? Because after sorting it, you will be able to find, at least out of those 5 points, I will be able to find the 2 points. Okay. So what 5 points I will be needing? I will be needing the minimum value. I will be needing the maximum value, 38, right? I will be needing the median value. Okay. Now, first of all, to calculate a median, I should know that how many values are there in this. So I feel like we have around 9 values, right? So the median value will be the middle value. So there is 4 values on this side. There are 4 values on this side. So this is the middle value. 34 will become our median. Okay. So minimum is 25. Maximum is 38. Median is what? 34. Now we need to find the 25th percentile and the and your 75th percentile, right? That is this is 25th and this is, let's say, 75th. These we need to calculate now. Okay, so 25th percentile is what it will be. So I have in total I have just 1 minute. Just 1 minute. I'm just thinking something, I think. Yeah, right. I was thinking, should I include this or not? Yeah, okay. So this much is there. Then what we need to do is we need to find the middle value of this and we need to find the middle value of this. Okay, so the middle value of this 25 to 34 is nothing but your 29. And the middle value between 34 to 38 is nothing but 35. Okay, so my 25th percentile is going to be 29. My 75th percentile is going to be 35. Okay, now what I need to do? All I have to do is I need to create, a chart, a x-axis. I'm creating a horizontal box plot. You can create a vertical box plot also. Okay. So let's say we start with,
Hello.
hello.
I had one query. How did we get the values of the second 75th percentile?
The middle of this.
Okay, from fourth.
Right, exactly. Yes.
Okay, thank you.
Sure. Now, I will start with 24. 24, let's say 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Right? So now I'll start marking things like one is the minimum value is 25th. So this is 25. This is my first point, right? This is the first point. 25. Then the second point is 29. So this is 25, 26, 26, 27, 28, 29. Right? This is my second point. And I can mark this as well. This is 24, 26, 28, 30, 32, 34, 36, 38, and 40. Okay. Now, so I have the minimum value, that is 25, the 25th percentile, that is 29, then the median value 34. This is my median value, that is 34. Then I have after this 35. That is my 75th percentile. That is my fourth value. And then finally the maximum value, that is 38. Okay. Now how we will create box plot, all we have to do is first create a, we first need to create a rectangular box, right, between second and fourth. Then this is the median value, like this one, and this, then this. This is a box plot. Okay, it means that this is the minimum value, this is the 75th or 25th percentile, this is the median value, this is 75th percentile, and this is the maximum value. Okay, this is box plots are very extensively used if you want to compare two distributions. Let me see, I think, yeah, here. Let's take this distribution, for example. Okay, here what we have, here we have the distribution of height between male and female. Okay, for now you can just ignore this part, this one. Okay, that I will explain later. For now, just ignore it. So now what it tells me, it tells me that the maximum height of a male is what? Around 176. And the minimum height of a male is what? Around 154. Okay, this is what it means, that the maximum height of a male is around 176. The minimum height is around 154. When I look at a female though, right, when I look at female, the maximum height is somewhere around 168, I believe. And the minimum height is somewhere around 146. This is how I should read it. For boys, the range of height is from 154 to 176. From 154 to, let's say, 176. On the other hand, for girls, the range of height is between 146 to, let's say, 168. This is one information that I can get from this chart. The other information that I can get is the median value for boys is around 168. Okay, so the median value is for boys, median height is 168. For girls, median height is for girls is around 158, let's say. Okay, so one thing that we can read is that the range is from 154 to 776 for boys. For girls, it is from 146 to 148. The median height for boys is 168. For girls, it is 158. Okay, what else we can know from this? We can also know the 25th and the 75th percentile. We can say that, let's say, from example, from here to here, right? Assuming this is, let's say, 163. So I can say that the 25% of the boys have their height between 154 to 156. Okay, so 25% people are here. Similarly, I can say that for girls, 25% of the girls have their height between 146 till here. This much. 25% girls have their height between 146 till, let's say, 153. Right? So we get a distribution of data, right? We get to know that how the heights are distributed for male versus female. Instead of just comparing two values, let's just comparing the average values or just comparing the median value, we are being able to compare the range of a continuous variable across these two categories. Okay, clear how to read box plot?
Yes, and like I have a question. Like above the mailbox plot, there are some dots. What are those?
Right. Those are
And
like outliers. So if you, let's say, for example, look at this, they say that the whiskers define the highest and the shortest individual, right? That is the maximum value and the minimum value, right? While the dots represents the outlier. Okay, the dots represents the outliers. So these are the outliers. Now the definition that these guys have used over here, anyone who is having uh, more than 1.5 times of interquartile range. Let's say this is Q3, right? This is Q3. So they are saying that any value which will be greater than Q3 plus 1.5 times of IQR, that is interquartile range. What is interquartile range? This is IQR. This is IQR. Okay, anything which is like beyond Q3 plus 1.5 times IQR. This much height they have taken as 1.5 times IQR. Anything which is beyond that, they have taken it as an outlier.
so they are like some of the people are in that range, so, but the number are very like low.
Right. So what they have done is that,
That's why.
like if the maximum value is, it's more like a case when condition. You can say that if the maximum value is less than Q3 plus 1.5 IQ, 1.5 time IQR, then take the maximum value. But if your maximum value is greater than Q3 plus 1.5 times IQR, then take this value as a maximum value.
Okay.
Take
So,
this value as a.
so just for example, first of all, we will plot this one. Then we have to revisit the plot. Then we have to make the changes. Is that so?
Right. To be so yes and no both. Why I'm saying yes and no both? Because these guys have done it this way. Like it is not a rule. You can also plot just using min max value, right? You need not to define your outliers like this. Okay, this is a common
Okay,
way of.
standard practice. Okay.
Right. This is a common way of identifying outliers, right? But this is not a rule, right? This is not something which I would say is used by 95% of the people, because even if it is used by 95% of the people, I take it as a rule, right? But this Q3 plus 1.5 IQR is just one of the way of doing things. It is not very standard. There are multiple ways of finding out outliers. Okay. And that's for the reason that I was trying to avoid discussing it here. You can just ignore it for now. Okay, because this is not a standard thing, but yeah, this is one of the way of identifying outliers.
For
No,
example,
one.
in the interview, if you are asked to plot something like that or similar to this one, so we have to ask the interviewer first, like if they want in that way or as it depends on person to person.
It depends upon, for example, how much time you want to spend on, let's say, this particular thing. Like in general, for an interview, they will not ask you. That is one thing, right? Second thing, if they ask you, like if I was you, I will just simply create a box plot like this, right? Without going into this 1.5 IQR and all of that. But yes, if he will counter question me, and again, everything is hypothetical, it is not going to happen in an interview. But let's say if he will counter question me that can you identify outliers, then yes, I will tell him. Then I will go into a different topic altogether, how to identify outliers, right? If I have identified outliers, I will remove them and then I will create this plot, right? And then I can plot outliers like this. These are outliers.
So we can also use this to identify how many outliers are there in our data set.
Right. Not to identify, to show outliers, right? To identify
Sure.
outliers, there are techniques to identify outliers. Okay.
Okay.
Once those outliers are identified, you can show show those outliers
Will
like
remove.
this, right? So for
Okay.
example, here I can say that there are 3 outliers. Okay, so
Okay.
the box plot will not tell you like there are 3 outliers. You can just show 3 outliers on a box plot. These are 2 different things. Okay, to identify an outlier, there are multiple ways. One of the ways is this thing.
We already know the value now, so we can just use that.
Right, right. So that is just one of the ways. This is what I'm saying. There are multiple ways.
Okay. So we remove these outliers because like why? I don't know.
We remove this outlier because that is not a generic thing, right? We remove outliers in general because we feel that it is just unnecessarily biasing the data. So for example, if let's say if I will not separate out outliers, this is how it will look like. Like right now it is looking like this. Let me make it black. Right now it looks like this, right? And similarly for girls. Right? Now, as of now, to me, it looks like this much area. This much is more or less this much, which makes sense also, right? The girls can be shorter than boys, but it's not like that the range varies drastically. Okay, if there are 25% of the boys are there between this height to this height, more or less this gap will be same for girls as well. But now just imagine if I had not removed the outliers, which outliers are what? Something which doesn't follow the general trend. Then how my whiskers will look like? My whiskers will look something like this.
So it will disrupt the like real information on the
Right,
basis of
exactly.
some like individuals.
Right. So this is
One question, like, when we know max and min,
Mhm.
so why are we, saying it as an outlier? That part I didn't understand.
Right,
So,
right.
that page number 22, can you go back, please? 22
Yeah, sure.
or maybe 24. Yeah, this one. So here, we are saying 175 as the max value, right?
Right.
175 and 154 for males I'm talking about. So whatever values above 175, whatever we have, those are outliers, but still that 184 value is termed as maximum only, right? Then why are we saying 176 as the max value?
Okay.
That part
Yeah.
I didn't understand.
Right. So let's call this point. This is 5th point, right? Let's say this one. Let me copy paste this slide again. Okay. Now, okay, if we want to like understand it in deep, let's say this is how we can do it. This thing is from here to here. Let's add few more terms. This is called IQR. Okay, interquartile range from here till here. That is one thing. Now, let's not call it max. Okay. It will be minimum of the maximum value or Q3. This is the Q3 value. This is Q3 and this is Q2. Okay, it is from this point we need to find minimum of maximum or Q3 plus 1.5 times IQR. Whatever is minimum of these two, that I will take. Similarly, here let's not call it a minimum. It will be maximum of maximum of the minimum value. If the minimum value is bigger, then I will take that. Or Q2 minus 1.5 times IQR. If your minimum value is smaller than this, I will consider it as an outlier. So I will stop my whisker there. And then the other values will come as a dot. Whatever will be outside this will come as a dot. And whatever will be bigger than this will come as a dot.
Okay. Yeah.
Okay, any other question, anyone?
Yeah, can you please explain this Q2 IQR? Not understanding. So
Okay, sure. And now to understand this, we actually need to make this chart vertical, because I think we understand. We have a habit of, let's say, for example, looking at numbers in a vertical format. So we'll try to see that. Let's say this is height. Right. So right now I have just plotted Q2. What is this? This is Q3. What is this value? This one?
Median.
Okay. And what will be this?
IQR.
Right? IQR, that is interquartile range. Okay. Now tell me, if I'm talking about height, okay. Now tell me what can be the meaning of outlier? Let's say I'm talking about the distribution of height of adult males, right? Adult male, I mean, let's say 20 plus people, right? What will be the meaning of outlier there? Someone who is very tall, let's say 10 feet tall, will you consider him as an outlier, or like it's a generic thing?
Outlier.
It's an outlier. Yeah.
It's an outlier, right?
He's taller than the average, like height.
Right. He's way taller
Way
than
taller
the
than way
average
taller.
height, right?
I mean, it is
But
out of the range of the whiskers that we are defining.
yeah, but we have not defined the viscous yet, right? So I'm just talking about, like, in general, if I'll talk about outliers, it will be a very big value. Like, for example, 10 feet. Can the outliers be a very small value as well? If someone is just let's say 1 feet tall, 1 feet is very small. Okay.
Yes.
If someone is 1 feet tall, can that person will also be considered as an outlier or not?
Yes.
Yes.
That person will also be considered as an outlier, right? So it means that a very small value, right, will also be considered as an outlier. A very big value will also be considered as an outlier, right? So it means that when I want to plot a generic trend, so then I don't want my maximum value to be very high. You got my point? I don't want my maximum value to be very high. So it means that what I'm trying to do is, let's say if I have, hypothetically, if I have, if this could have been the whisker, or this could have been the whisker, this could have been the whisker. So I'm just trying to make sure that whisker should be like a little bit on a smaller side, not very big, right? Similarly, if I look at the other end, what is an outlier? An outlier is a very small value, right? So I don't want, like, the more in depth the whisker will go, the more in depth the whisker will go, right? The smaller the value it will cover, and that is something that we will consider as an outlier. Okay, so what we will do is, I said to find the whisker value, right? To find the first point and the fifth point. Let's talk about the fifth point first. I said we will be taking minimum of maximum and Q3 plus 1.5 timeout. So I said the fifth point is going to be minimum of the maximum value and Q3 plus 1.5 time IQR. Okay, let's first plot 1.5 times IQR, right? Hypothetically again, right? This is 1.5 times IQR. This point is Q3 plus 1.5 times IQR. Similarly, on the below side, this point is Q2 minus, right? Like if you want to go down, this point is less than Q2. So it will be Q2 minus 1.5 times IQR. Right? Because what is our first point? Our first point is the maximum value. It means the bigger value. Bigger of either the minimum value or Q2 minus 1.5 times IQR. Okay. Now I will discuss different scenarios. One scenario is that your max.
Do we always have to like define this value for our whisker, like whenever we are making box plot, or it will do it naturally?
It depends. Actually, the different package create your box plot differently. So we need not to do it on our own, first of all, right? If your package by default is considering 1.5 IQR as a outlier, then it will itself keep those data points outside.
Okay, but this is the logic behind it.
Yeah, this is the
That we
logic
are
behind
taking
it. Right.
25%
Exactly.
to 75% values, and we are just multiplying it by 1.5.
Right.
Okay.
Okay. Now, just hypothetically, the maximum value is less than this, right? The maximum value can be anywhere here. Let's say, for example, let's say it was here. And the minimum value was somewhere here. Then we don't care about this range. We don't care about this range at all, right? Because my maximum value was this. Let's say this came out to be the maximum value. Because my maximum value was less than this value, I need to take a minimum of the maximum value and Q3 plus 1.5 IQR. So between these 2 points, which one is the minimum?
The max value.
The max point, right? So this is where the whisker will end. And similarly, if this is the minimum value, right? Between these 2 points, which one is the maximum value? Which is the bigger value?
The minimum one.
The minimum one, right? This is a bigger value as compared to this, right? Let's say, for example, if this is 0 and this is 100, it is increasing like this, right? So between this point and this point, which one is the bigger point? The minimum point.
Value. Yeah.
Right? So let's say this is this scenario. Here there is no outlier altogether. Or the second scenario is one more scenario let's discuss, right? Where maybe the maximum value is actually greater than this. This is the maximum value. So ideally the box plot should have been this. This is the maximum value. Now between maximum value and Q3 times Q3 plus 1.5 IQR, which one is a bigger value? Which is the
Max
minimum value?
value.
So yeah, yes,
Q3 plus 1.5 IQR is a lesser
minimum
value.
value, right? So because it is a lesser value, what will happen? The whisker will end here. The whisker will end here. But there are points between this and this. That's why there is a maximum value here, right? There are points between this and this. Those points will be shown as dots. Okay, the same thing can happen on the downside as well. The same thing can happen on the downside as well, where let's say the minimum value was actually smaller than this. This was the minimum value. Okay, now between the minimum value and Q2 minus 1.5 IQR, which one is a bigger value?
Q2 minus 1.5 times of IQR.
Right. So we will create a whisker here, and then whatever the values which are lesser than this, we will show it as like this. Okay, is it clear? And now obviously it can be on the both side as well, right? This could have also been the case that the minimum value is also lesser than this, and the maximum value is also greater than this. In this case, we will be building whiskers till here. Similarly, whisker till here. Value greater than this will be dots. Value smaller than this will be dots. Okay. Clear? Any question?
So box plot help us detect outlier, right? The usage of box plot.
Or we can say it's the other way around as well, right? Like first what you have done is you have created a definition of outlier yourself. You said anything greater than Q3 plus 1.5 IQR, I will be considering it as outlier, right? And I will be presenting it like this. Right? So yes, in a way, the box plot is telling you what the outlier is, but it's like this is a definition that you have decided on your own. This is not a standard definition. Okay, it is used by many people, but it is not a rule. Okay, like no one can force me to say that okay, anything which will be greater than Q3 plus 1.5 IQR, that will be an outlier. No one can force me to like kind of do that. But yes, it is one of the definition that the people use.
So, is there a general guideline to define IQR, or that is also?
No, IQR is fixed. IQR is the interquartile range. It is a definition. It's a mathematical term.
Okay. So between 25th to 75th percentile is the IQR.
Right. Exactly.
Okay.
Nice. So let me show you a few. Okay, so these are just an example of like for example, different kind, the way the people create box plot. Okay, let me show you the one with an outlier. Yeah, for example here. Okay, so here the dots that you see outside is something that you can consider as an outlier. And this is a definition, for example, the people sometimes use. This is Q1. Yeah, it's not actually, yeah, my bad. It was not Q2, it is Q1. Okay. So Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. The values which are greater than that are shown as dot and are called outliers. Again, this is one of the way of doing it. Okay. This data point is an outlier. Okay, any question? Okay, then let's move on to the next part. When do you use Apurva? Apurva, like as I said, right? If I want to compare the height of between the heights between male and female, the one way can be I can say that a very rough way will be male are taller as compared to female. This is a very rough way of like putting the comparison. A person maybe who needs more detail, I might say that okay, on an average, the guys are of 168 centimeter, the girls are of 158 centimeter, right? So the first statement, when what I said, male are in general taller than female. This is passing on information, but it is not very specific. In the second statement, I made it more specific. On an average, male are of 168 centimeter, female are of 158 centimeter. This is a second scenario, right? Or a third scenario can be where someone wants to go more into detail, then maybe I can show them a distribution like this. That this is how the height are distributed between male and female. Now, out of these three scenarios, the three possibilities, which one you want to use will be depend upon your case to case, like how much detail that you want. Like what is your purpose of asking this question? Like how male and female are different in terms of height. Like what is the purpose of that? Okay. Depending upon that purpose, the question can be answered in three ways. As I said, one thing I can just say simply male are taller than female, right? Like for example, if my kid will ask me, Papa, what is the difference between the height of male and female? I will simply say that okay, males are in general taller as compared to female, right? Simple question, simple answer. But if he needs more detail, then okay, I will put average. And if it's like someone who wants to go more into detail for some research purpose, maybe we'll put this distribution. Charan, your question is very valid. It's just that in general, outliers are very small percentage of data. Okay. So let's say if I have 10,000 points, then the outliers will be 2, 3, 5, 10 outliers, not more than that. So it will not change your 25% distribution drastically. Okay. Because let's say there are 10,000 data points, then in each bucket, there are 2,500 points, right? 25% of 10,000 points is 2,500. Now, even if I will remove 3, 4 data points from the last bucket, I can say still more or less it is 25% of the data. Okay. Outliers cannot be significant proportion of your whole data. If it is a significant proportion of your whole data, it is not an outlier. Outliers means something which is not following the general trend. So it cannot be a lot of data points. Okay. One other thing is, so the next topic is the measure of central tendency. Okay. This is how, like, in stats book, you will find this topic, measure of central tendency. Okay. Sounds fancy, as if we are going to do something very math heavy and all, but it is nothing but just mean, median, and mode. Okay. Measure of central tendency is nothing but mean, median, or mode. Okay. I hope you guys already understand what mean, median, and mode is, right? But I will give you a very high level detail. First of all, where mean, or what we call it like the average, is used. Okay. So the average or mean is used, I have seen mainly in three cases. First case, when I want to give a simple answer to a simple question, right? Let's say if my CEO will meet me in the lift and he will ask me, okay, Puneet, what is our sales these days? He has asked you a very simple question in a lift, right? You cannot give him like a very long explanation that, okay, this is how it is varying month over month. And obviously I will not even remember those numbers, right? But he has asked me this question, that what are our sales these days? I can simply say that, okay, on an average, we have a revenue of, or we have a sales of 2 crores per month. It is a simple question he asked. I gave him a very simple answer. Okay. So whenever you want to give a simple answer to a simple question, you can simply use an average. That on an average, these many orders we are getting. On an average, this is how much we are spending on marketing. On an average, this is how much the humans wait, right? This is on an average is a wait time. On an average, this is what is the rating of my restaurant. Okay, a simple answer to a simple question, you can use averages. Second place where I have seen that we can use averages to compare two things. Right? If you want to compare two restaurants or two, let's say, different jeans that you're planning to purchase, what do we compare? We compare their average rating. We see that, okay, one product is rated, or one restaurant is rated 4.5, another one is rated 3.9. So most probably the one which is rated 4.5 will be better than 3.9. Okay. So whenever you want to compare two things, you can use averages, average of both the things. And then the third thing is, the third situation in which we can use averages to compare one data point with the rest of the distribution. When I want to compare one data point with the rest of the distribution. Let's say again, same thing. I met my CEO in the lift and he asked me, Puneet, how we did in terms of sales last month. Okay. So what he wants to understand, whether we did good or we did bad, all right, in the last month. So how will how I will decide whether the last month was good or bad? I will just compare the last month sales with the average sales. If on an average I get 2 crores of sales per month, and if last month I got 3 crores of sales, then last month was better as compared to the other months. If on an average I get 2 crores of sales, but if last month of sales was, let's say, 1.7 crore or 1.6 crore, I can say that the last month was comparatively, I would say, bad as compared to the rest of the months. So what we are doing here, we are comparing the one data point with the rest of the distribution. Okay, so averages are very helpful in this way. Okay, they help us in answering questions, simple questions in a simple manner. Okay, where do we use median? Actually, I will tell you later that but median is something which is more accurate as compared to mean. If you want to show the center of a distribution, but in general, I have seen that it's a little hard to grasp for most of the people. Okay, so the people talk about average basket size, the people talk about the average height, average income. All right, although median is a better way of presenting the center. Why? Because averages are more easy to understand for the people as compared to median. Okay, so that's why at most of the places you will be seeing averages being reported instead of median, although median is a better measure of central tendency as compared to average. Okay, then what is the use of median? If we are not going to report it anyway, all right, then what is the use of median? The use of median is, so the median will be used to identify the outliers. Okay, median is used to identify outliers. Okay, if median is let's say if your, let me put it other way around. If your mean is lesser, like way lesser, a little bit variation will always be there. If your mean is very less as compared to median, it means that there are small outliers in the data.
Can you please explain that median and mode once again? I didn't understand.
Sure, I'll come back to median and mode again, right? But median is 50th percentile. How to calculate it and all?
Yeah, that part I understand. Like, when do we use it?
Yeah, I've not discussed that yet. Okay, median is used to identify outliers. That's what all I have said. So when your average or the mean value will be way lesser as compared to median, that indicates that there is a probability that you have very small values, right? It means you have small outliers in the data. On the other hand, if your mean value is very large as compared to median, this indicates that you have big outliers in the data set. Okay, when your mean value is approximately same as median, then we can say we have no outliers. Most probably we have no outliers in the data. Okay, so this is what median is used for. Okay, if mean and median are same, then it doesn't matter which one you are reporting. So always report mean. Okay, if mean and median are approximately same, then it doesn't matter which one you are reporting. So always report mean, that is the average. If mean and median are very different from each other, it means that they, like, most probably we have outliers in the data. So remove those outliers, calculate the average again, right? And now when the average and median will be similar to each other, again report average, that is mean. If mean is very big as compared to median, it indicates that you have big outliers in the data set. Again, remove those outliers, treat those outliers, then calculate the average again so that it is closer to median, and again report mean. Okay, so for reporting we always use average. It's just that we try to make sure that the average and median should be close to each other. If they are not close to each other, it means that we have outliers and we need to treat for those outliers. Apurva, there is nothing good or bad about outliers, right? To be very frank, no one wants to have outliers in the data, right? But it is not something which is in your control. If we will have outliers in the data, we will treat it. How we will treat, again, we will discuss it later, right? We will treat it and then we will use the data. If there is no outliers, then anyway we need not to worry and we will use the data directly. Okay, and what can be the reasons of outlier? Outlier can be because of many reasons, right? For example, when you will plot sales of Flipkart over the period of time. If I will plot sales of Flipkart over the period of time, let's say this is Flipkart sales over the period of time. For a year I'm talking about. This is time. So what is happening most probably on this? This looks like an outlier. So what is happening on this? Most probably they had a big billion day sales, right? You have big billion day sales on this particular day. Yeah, sure, Lavanya. Yes, we can have a break. Let's connect again at 11:10. Okay. Okay, we'll start in 30 seconds. Okay, let's start. So I was saying that, when it comes to outliers, there can be multiple reasons behind outliers, and it's important sometimes to understand the reasons behind it. For example, big billion day sales might look like an outlier to you because it is significantly higher as compared to the rest of the point. But if you will remove big billion sales from the calculation, right, it will show a very incorrect picture of Flipkart sales, right? Because there 20-30% of the total sales happens around big billion days, right? So if I will remove it altogether, it will show a very different picture for Flipkart. So if I understand that why this outlier is coming, based on that, sometimes we might want to keep it. Okay. If we know that there is a valid reason behind an outlier, we might want to keep it. Now, what is mode? Mode is the most frequent value, right? So for example, if I have 1, 1, 3, 9, 7, 5, 3, 8, 9, 1, 10, right? If I have these values, if I'll ask you what is the mode, and the mode will be
One.
One.
it is 1. The mode is 1 or something else.
Yeah, one only. It's repeating
One
3
only.
times.
Right.
One.
Now, what if I add, you are correct, the mode for this is 1 because 1 is the most frequent value. How many ones we have? 1, 2, 3. We have 3 ones. And there is no other point, other value which is repeating 3 times. Now, what if I have one more value? 9. Now I have 9 which is getting repeated 3 times. 1 also getting repeated 3 times. Then what will be the value of mode? If someone will ask me what is
9.
mode?
9. If they have
9?
the same number of values, because 9 is like bigger than 1. I think that's why it will take 9.
No. Actually, so what happens is when it comes to mode, there can be multiple modes in a data set. Okay. So in this case, like the case that you are seeing here, we will say, no, not or. We will say that 1 and 9 both are mode. Okay. So there can be multiple mode in a data set. If there are two values which are equally frequent, then both are mode. Okay, now let me ask you a question. Let's say there are two restaurants. Restaurant 1 and restaurant 2. Okay, and they have different star ratings. Let's say some 1-star rating, 2-star rating, 3-star rating, 4-star ratings, and 5-star rating. Similarly, for this one also, I have the people have given 1-star rating, 2-star rating, 3-star rating, 4-star rating, and 5-star rating. Right? Let's say here the people have given 15 people gave me 1-star. 2 people gave me 2-star. 2 people gave me 3-star. 33 people gave me 4-star. Let's say 48 people gave me 5-star. Similarly here, let's say 3 people gave me 1-star. 11 people gave me 2-star. 13 people gave me 3-star. 32 people gave me 4-star. And let's say 41 people gave me 5-star. Okay. Now, when we look at restaurant 1 and restaurant 2, do you think that they are similar to each other, or like based on the reviews that you see, do you think that they are similar to each other or they are different from each other?
The distribution is increasing, but they are different, but the distribution is there, like
Somehow
41 has
is the
given 5
values
stars, 40.
are
If we have to make a like pattern, we can just look at it.
Okay. So you are saying that they are somewhat similar?
Yes.
Right. So now
Distribution is somewhat.
So
distribution is somewhat
4-star
similar.
and 4-star and 5-star ratings are similar, but if you look at 1-star, 2-star, and 3-star, they are not similar.
Yeah, very nice. Right. That's a very good point. So what we are seeing over here in the restaurant 1, either it is 1, the 1-star, or it is 4-star or 5-star. Very few people have rated them 2 or 3-star. Right. So it means that if they fuck up, they fuck up big time. Okay, or otherwise they do it good. Okay, so there is nothing like the people are not giving 2-star or 3-star. They are giving either 1 or a 4 or 5. So it means that if they are doing bad, they are doing bad by a significant margin, or they are doing good. But when I look at restaurant 2, there are not many people who have rated them 1-star, right? But there are people who have rated them 2. There are people who have rated them 3. There are people who have rated them 4 and 5. So it means that it is very nicely distributed. Okay, and very few people had like a very bad experience with them, right? Because there are very few people who have rated them 1. Okay, so although the restaurant 1 and restaurant 2 similar, but maybe underneath this distribution, maybe two a very different kind of things are happening. Maybe restaurant 1 is dealing with a different kind of a problem, and restaurant 2 is dealing with a different kind of a problem. Okay, but if you look at the averages, like these numbers that I have put, these numbers are not random. I have put those numbers in such a way that if you look at the average of restaurant 1, it will come out to be 3.9. And if you will look at the average rating of restaurant 2, this will also come out to be 3.9. Okay, the averages of both restaurant 1 and restaurant 2 are exactly the same. But the kind of distribution that we have in restaurant 1 and restaurant 2 are different. So although if I will just look at the averages, if I just look at the average, it might seem that the restaurant 1 and restaurant 2 both are same, but when we look at the distribution, it looks like that the both maybe are dealing with different kind of problems.
So average rating always cannot solve our problem. I mean, there's more than that.
All right, exactly. Very good point. Right? And this is the point that I was planning to make after this. That average might not be giving you the full picture. Okay, so we have talked about measure of central tendency so far, right? Mean, median, and mode. All three are considered measure of central tendency. Okay, but the averages can be limiting. Okay, it might not show you the full picture. And that's why there's a second concept of statistics comes into picture, which is called measure of dispersion. Measure of dispersion. How much distributed the data is. Okay, now let's try to understand it using an example. Let's say this is 12, this is 13, this is 14, this is 16. Okay, let me copy paste this. Okay, I have three scenarios. I will plot 1, 2, and 3. Okay, and we will try to see that why measure of central tendency not always give you the full picture. Okay, so let's say this the x-axis that you have, it has values like 12, 13, 14, 15, and 16, right? Similarly for this also. This is my x-axis. And I have like these data points. I have one data point, which is 12. I have one data point, which is 13. I have one data point, which is 14. One data point, 15. One data point is 16. Or I can have this. One data point at 13, one at 14, one at 15, and two more data points at 14. Right? So there are total 3 data points at 14. One is at 13, one at 15. Or let's say all the 5 data points, are at 14 itself. Okay, let's say these 3 scenarios are there. In the first case, what is going to be the mean? What is the mean of this distribution?
14.
14. And what is the median of this distribution?
It's again 14 only.
It's 14. Very nice. If I'll ask about this, what is the mean of this distribution?
14.
14.
14.
And the median?
Again,
Second 14.
Right. And similarly, let's say if you look at this also, right, because all the data points are exactly the same, so mean will also be 14 and the median will also be 14. Right. So if I'm focusing just on the mean value and the median value between these 3 distribution, I cannot differentiate. Just by looking at the mean and the median value, these are exactly the same distributions. Right? But are they exactly the same distribution? The answer is no. These are not the same distribution. But if you just look at the measure of central tendency, that is the mean and the median, it looks like these are exactly the same distribution. So it means that we need something more than mean and median. Okay. So what should I do? What should I calculate or add which can differentiate between these 3 distributions?
we can look for maximum, minimum.
Very nice, right? Very nice, very nice, right? So we will say that we will calculate range maybe, right? Range is nothing but your minimum value and the maximum value. So in this case, the range will be between 12 to 16. In this case, the range will be from 13 to 15.
13 to 15.
And in this case, the range is going to be from 14 to 14. So it looks like the range have most probably solved the problem that we were having. We were not able to differentiate between these three distributions using mean and median. Here, I'm being able to distinguish between the three distributions using mean and the median. Okay, but let's look at one more scenario. Let's look at this scenario. This is 12, 13, 14, 15, 16. This is 12, 13, 14, 15, 16, and let's say 17. Let's look at another two scenarios. Let's say scenario 4 and 5. Okay, scenario 4 is I have most of my data points centered around 14. One data point is at 12, one is at 16. Versus two data points at 12, two data points at 13, two data points at 14, two data points at 15, two data point at 16. So what is going to be the range in this case?
12 to 16.
Ranges
12 to 16.
In this case also
Same.
12 to 16. So although the range solved somewhat problem here, right? But here it is failing. It is telling me that the fourth scenario and fifth scenario are exactly the same. Okay, and if you calculate the mean and median also, in the first case, the mean and median is 14. In the second case also, the mean and median is 14. So even if I will combine mean and median together with the range, right, it is not sufficient. Frequency we can add, Aman, you are right, but let's say just imagine if there are so many values, if there are a lot of values which are there, if there are 10,000, 20,000 values are there, then adding frequency will become like very difficult to track. Okay. Right, Vinay, you have a good point. Yes, that's correct. We are moving towards that, right? So it means that even the range is not sufficient. Okay, so let's calculate something else. Okay, let's calculate this. Again, same case. This is 12, this is 13, 14, 15, 16. Okay, this is 12, 13. So we will try to come up with a metric which is not changing a lot, right? It should be able to cover all kind of scenarios. Okay, so let's say I have this one data point here, one data point here, one data point here, one data point here, and one data point here. So what I will be calculating is I will be calculating the distance of each point, the distance of each point from the center, that is from the mean. Okay, so for example, this is something that I will consider distance 1 because my mean is at 14. Okay, my mean is at 14. So this is what distance 1 is. The second point is at a distance 2. Third point, that is this point. This is distance 3. It is on the mean itself. Okay. Then this is distance 4. And finally, this one is distance 5. Okay. Now what I will do is I will calculate each distance. Distance 1 is what? Your 12 minus 14, like 14 being the average, minus 2. Distance 2 is 13 minus 14, that is minus 1. Distance 3 is 14 minus 14, that is 0. Distance 4 is 15 minus 14, that is 1. Distance 5 is 16 minus 14, that is 2. So my average distance is minus 2 plus minus 1 plus 0 plus 1 plus 2 divided by whole thing divided by 5, which will be 0 by 5, which is 0. Now, is this correct? Is it right to say that, the average distance from mean is 0? Yes or no? What do you think?
No.
Yes, it is.
No, right? Are you saying that all the points are on the average itself?
Okay.
No, right?
No.
Right? When we say average distance from mean, I'm saying that on an average that is 0 distance. It means that everyone is on the mean itself. Right? That is not correct. So it means that I need to remove the signs. The problem is with the sign. I have minus 2, ideally it should have been only 2. This minus 1, ideally should have been only 1. And when
So
we
we
want
should
to...
look at,
Uh-huh.
so we are looking at the unit size rather than the absolute value.
Right, exactly. Right. So it means that I want, like, if you look at from a mathematics perspective, right? If there is a sign in front of a number and you want to remove that sign, what is the way to do that?
Mod of any numbers.
Mod
We
of any
can
number?
multiply it minus 1.
No, but if I'll multiply everything by minus 1, then what will happen? This will become 2, 1, 0, minus 1, minus 2. Like I need to have a
Only
generic formula, right?
we can use the function absolute also.
Right, we can use the absolute function, right? As he said, maybe what we can do is we can use mode. Okay, we can use, from a mathematics perspective, it will be called mode. That is one way. What is the other way, or other popular way of removing sign that you have used?
We can square it up. I mean, any negative number, if you square it, it will turn to positive integer only.
Very nice, right? So actually there are two ways in which the signs of a number can be removed. One is by taking the mod of it or absolute of it, right? And the second way is by doing a square of it. Okay. Now, in statistics, and this is, you can take it as a rule, you will not find any exception to it. In statistics, whenever we want to remove the sign, we will always be taking the square. We will not be taking the absolute. Okay, there are reasons behind it. Again, not some, like everything I can tell you just like on the spot right now, but I will tell you later why this happened. Okay, in statistics, always and always, whenever I want to remove sign, I will be taking a square of the numbers. Right? So if I have two choices, I will always be taking the square. Now, if I'm taking the square, this will become 4 plus 1 plus 0 plus 1 plus 4 divided by 5, which is what? 4 plus 5, 2. Right? I've done it right, right? 4
Yes.
plus, yeah.
Yes.
Okay.
Yes.
It is 2. So is it right to say that on an average, each data point at a distance of 2 units?
No.
No, right?
Yes.
There are only
Yes.
2 data points out of 5 data points which are at a distance of 2. So how can I say that on an average, each data point is at a distance of 2? So what is missing in this?
We can square root it after.
Right, exactly. So whenever you are squaring to remove the signs, right, you need to square it back. You need to take a under root of that to make sure that you are not inflating the numbers. Okay, so it will be under root of this. It will be under root of 2. Under root of 2 is what? What is the value?
1.414.
Right, very nice, right? 1.4. So we are saying that on an average, they are at a distance of 1.4. Okay, and the thing that we have just calculated, this number that we have just calculated, do you know what this number is called? The thing that we have just done, the process that we have just followed, this number is called standard deviation. Standard deviation. Okay, this thing that we have just calculated is called standard deviation. Standard deviation. Now, if someone asks you, okay, see, understanding is a very important part, right? Don't remember the formula, remember the definition of something. If the people ask you what is standard deviation, right? Like when we ask people, okay, what is standard deviation? They tell us that, okay, it is under root of, like the formula is this, summation of xi minus mu. Xi is the data points, mu is the mean square divided by n. Standard deviation is this, right? But you should not remember it like this. You should say the standard deviation is measure of distribution of data around the mean. This is the main part. This is what we should know. We should not say the standard deviation formula is this. No, the standard deviation is measure of distribution of data around the mean. Like from the average, how much distributed your data is. More distributed it will be, higher the value of standard deviation. Less distributed it will be, lesser will be the value of standard deviation. Okay, because we are anyway on this topic, let me introduce you with one more term, variance. Variance is nothing but square of standard deviation. Okay, because sometimes people use the term variance. Variation is nothing but square of standard deviation, which is nothing but summation of xi minus mu square divided by n. Under root will not be there. Okay, so if you are reporting standard deviation or variance, it is more or less the same thing, right? If it is variance, I know that I need to take a under root of that to find the standard deviation. Okay, but the important thing to remember is, what is standard deviation? Standard deviation is the distribution of data around the mean.
And how can we define variance in words?
Variance is in general defined as square of standard deviation. Okay, and then the standard deviation is defined as distribution of data around the mean.
Okay.
Okay.
So whenever we talk about the distribution of data, we'll focus more on standard deviation only, not on the variance.
Right, exactly. You're right.
Okay.
So Puneet, in the above slide, in one slide back, calculate standard deviation. We did addition of all the values and then took a square root.
Right.
Formula is showing as minus of mu square.
Yeah, I'll show you what it means. All right. It is saying xi minus mu square, right? So here, what do I mean by that? This is xi minus mu. 12 minus 14 square you are doing, right?
Got it. Got it. And then summation of all.
Then the summation of all, right?
Thanks.
Okay. Now, my question to you is, right, here, this is the average. Sorry, I don't know why I rubbed it, but these three distributions are centered at the same mean. This is the average, 100. And look at the standard deviation of each distribution. Like for example, the blue one. All right. For the blue one, this is what the distribution is. For the blue one, this is what the distribution is. All right. And what is the standard deviation of this? 5. Okay. Now, between this blue one, the one that I've just painted, right? Between this one and let's say the other one. Let me pick something like this, for example, the pink one. Which one is more distributed according to you?
The green one.
The green one, right? And that's why the standard deviation of this green one is more as compared to the standard deviation of the yellow one. So yellow one has a standard deviation of 5, and that's why it is more concentrated around the mean. Okay, green one has a bigger standard deviation. It means that it is more distributed around the mean. And similarly, when it comes to the red one, the standard deviation is even more higher. That is because it's 20. Okay, the data is even more distributed around the mean. So bigger standard deviation should like immediately, like in your mind, right? Immediately should click you that, okay, it means that the data is very distributed. Okay, a smaller standard deviation, it should immediately means to you that the data is very concentrated around the mean.
Yeah, one question. So here, right? Is a mean? Mean is average, right?
Mean is average, yes.
Yeah, here 20 is mean and 10 is also a mean and 5 is also a mean.
No,
in this.
No. This is what your what should I say? This one, right? This one is your average. 100 is an average. Here again also 100 is the average.
Okay.
And here again also 100 is the average. So the mean is same for everyone. Okay.
And the distribution is all about selling point. How much is sold?
Sorry, what is selling point?
It's distribution means here.
Distribution means here. So okay, I'll tell you what is on the y-axis. So maybe that will make things a bit more clear. Okay, on the y-axis, I have percentage of data points. Number of data point or percentage of data points. Okay, so most of the data points in the first distribution are concentrated around the mean. Like if you look at it, all the data points are between these 2 points. Here, all the data points are, let's say, between this and this. The range if you talk about it is from 70 to 130. Here the range was, let's say, 90 to 110. Here the range is even bigger, right? Maybe from 50 to 150. Okay.
Yeah, and one more. This mean is it's like looks like a medium, right? This 100.
Yeah, because it is a symmetric distribution, right? We call it a normal distribution. It's a symmetric bell-shaped curve, right? So in this case, mean and median will exactly be the same.
Okay.
Okay. If it is symmetric distribution, the both will lie at the center. Even the mode will exactly be the same. So 100 is mean also, median also, mode also. Because the most frequent value is this. This is the most frequent value, right? 100. Because most of the data points have value as 100. So mean, median, mode, all are exactly the 100.
Okay. Thank you.
Any other question, anyone?
Like, what is the effect of outliers, like when the standard deviation is more or less? Can you please explain that?
So let's look at the formula, right? Let's say, for example, here, what do you think? Let's say if we will add a point which is having a very high value or a very low value, will the standard deviation increase or decrease? What will happen?
The closer the value, the standard deviation will almost remain same. It will be
No, but let's
increased.
say, okay, just for the argument's sake, let's say my value is, somewhere here at 30. This is an outlier, right? As compared to the other points, or
Yeah,
if not, right? So now, if I will add one more data point, which is here, will the standard deviation increase or decrease,
yeah,
or
it will
remain the same?
increase.
Yeah.
It
So
will
that will be
increase.
the impact of outlier. So if there is a very big value, it will change the standard deviation.
Okay. Yeah, got it. Thank you.
In this case, the mean will also increase.
Yes, mean will also increase. You're right. Okay. Any other question, anyone?
So using this standard deviation, we can accurately point out like what is the outlier then. Is my statement right?
Yeah, I will come to that outlier part later, but yes, more or less, yes.
Okay.
Okay, this part, the outlier thing that you mentioned, we will discuss it in like more detail later.
Okay, yeah.
Okay, I will not start the next topic because we have like very less time and that topic will take at least half an hour to cover. So if you have any question on whatever we covered today, we can discuss that. Otherwise, this is all for today.
Yeah, in the below in the screenshot, right, in the below slides, right? Can you please explain me how finding the exact mean?
Like here in this one?
Yeah, here. Yes, yeah.
Like the mean is always the centered value.
Okay.
Right? Like if you look at any of these chart.
Okay, always middle
Value, right?
Okay.
Yeah. So if I'll draw a line at the center, right?
Okay.
It will cut it into two equal halves, right? One half is this, and exactly symmetrical half you will see on the other side, right? So you will find the mean at the center.
Okay.
Okay, because just like this, just like these values. If I know that this is very symmetric around 14, right? There are 2 points here, 2 points here. So the middle value is mean.
Okay.
In the same way, if I know that this is exactly the similar distribution around 100, then 100 is going to be the mean.
Okay. So and medium also you said same, right?
Median also will be same, yes.
So how could you please explain?
Like how median will be same?
Yeah, yes, yeah.
Right. The same thing. Let's say, for example, here. Now, if I will ask you to calculate the median is what? The middle value. So this is my first data point. This is my second data point.
Okay.
This is, let's say, one data point on this side. One data point on this side, one data point on this side. So two data point here, two data point here. So this will become your median value.
Oh, okay, okay.
Right?
Got
The
it.
middle value is the median. So in this case, the mean, median, mode, not mode here, but yeah, here the mean, median are exactly the same.
Okay. Thank you.
Okay. Mean and median need not to be same, and that's why there are two different words, mean and median, but they can be same. Okay, so for example, in this case it was same. In these cases also it is same. Okay, about the book part, just give me 1 minute. The author name is the foreigner, so I just don't remember the author name. Let me grab my book and I will tell you the author name. Just 1 minute. Okay. Vinay, maybe you were right, but sorry, I have not read that book. Okay, but if it is a good book, I will also try to read it. Yeah, this one. It's just that instead of application in R, because R is now a little outdated, take this one. Application in Python. With application Python. Again, I am not recommending anything for now. I feel that in the starting, because you have opted for this course, please stick to it. But still, if you want to go into more details, you can check this particular book. The other thing is that the course that we will be taking, right, the order of topics that we will be covering will not match with this one. Okay. So my suggestion will be wait for the course to get completed. Then if you want, you can read this book. This is a very popular book. Okay. And if you want, you can download a PDF file also. I'm pretty sure the PDF file is also readily available. Okay. But again, my recommendation will be not to start the book before this module end. Okay. Yeah, that's all, guys.
Can you please upload those PPTs and Excel sheet?
Yeah, sure, sure.
in the
Actually,
drive?
I was not able to do it yesterday. I didn't have the link. But now I have the link, so I will do that.
Yeah, can you please share that link in the chat?
I
Share
don't
drive
have
link.
it here. Just 1 minute. 1 minute. Okay. I put it in the chat. Okay. Thank you guys. I will see you next week. Bye-bye.
This seems to be some A/B testing is there. It's not the one I believe.
I'm
Can
not sure.
can please
I've not opened it, to be very frank, yet. This is the one that they shared with me last night. I will check it. Like, this is the only link that I have. Okay, so if this is not correct, I will open it and I will check. I have not checked it yet. But if this is not correct, I will ask them for the right link. But this is the link
okay.
that they have shared.
Okay, yeah.
Okay. Thank you, guys. Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you. And one more thing, guys. In case, obviously, I will not be able to share the link with you for till the next week. So if you want to revise the topic, just ping it on the WhatsApp group itself that you need the drive link. Okay. So I am pretty sure that they will provide you the link on the WhatsApp group itself. So don't wait it till next week. Just ping it on the group and they will share it with you. Okay. Thank you. Bye-bye.